My roll number is IMT2018078. My name is Tanmay Arora. I will now press A and load all of the objects on my screen. After I've done that, you can see I've assigned them all different colors and different ambient light, ambient coefficient, diffuse and specular, everything. And I have assigned them different values for their IDs, which is 4, 5, and 6. After I've done this, I can press M and go into the mesh transformation mode, where I can show translation, scaling, and rotation by pressing down on the mouse and moving it around. I can do the same for all the other objects as well. Uh, Scale up, scale down. I can do the same for this object as well. After I've done that, we can now look at the different shading models, which are the Gouraud and Phong shading model. The default shading model is Gouraud, which we can see here, and how it reflects the light off of the surface. I can press S and change it to Phong shading model. We can see that it is a much defined and sharper specular highlight as compared to the Gouraud, which is not this. After we have done this, we can now look at how the light sources can be turned off and on. I can press 0 on the selected mesh and I can turn the light source off. If I go to a different object and come back to it, and do not press 1 to turn the light on, it will not be turned on. Only when I go to that object and press 1 to turn the light on, only then the light source will be turned on. Now let's look specifically at how the light sources and move with respect to the object. So if I am not, if I'm just translating the object, the light sources move with the object. They do not, so that they do not violate the bounding box constraints. I can press Z to move it to the left, and then I can show it. I can press Z to move to the left, and then show that it moves around with the teapot. Then I can press X to move it to the right. Then I can press C to move it down. Then I can press V to move it up. Then I can press B to move it inside the plane. And I can press N to move it outside the plane. In the middle, you could see that when I went left for too long, it violated the constraint. And that is what what you're going to look at. So let's imagine a bounding box around this. The light source goes too far away and then it varies the constraint. Now, since the handle of the top of the teapot is present here, the bounding box constraints have changed, and now it will not violate the constraints of the bounding box. So if I move it a little bit to the right, it will then start violating the constraint because the top of it does not exist there anymore, and then it will violate the constraint. I can do the same. We can look at the same by scaling the object down. We can see that it violates constraints when I scale it down too much because bounding box size decreases, and then the light source is too much away from the object. We can also see two other things. First is the code for the bounding box. We can see that what I've done is that I've done a transformation on each and every vertex, and then I created a bounding box around that object, and I calculate the distance from every side of that bounding box. And if that distance is less than a specific value that I've set, only then will my light be set to a specific position. Otherwise, if that distance is greater than the specified value, it will log me as equivalence constraint of the object, and then it will set the position of the light as inside that of the object, which is what we can see here. The light is coming from inside the object, which basically tells us that the constraint has been violated. And the other thing, we have been asked to implement a blend form local illumination model, which is what we have achieved here, because we are using the half vector as opposed to half vector of the surface to light and from the surface to view, as opposed to calculating the normals every time. So we just look at the half vector and not both of them individually. That's it. Thank you.